Okay, so from our power reducing formulas, if we rearrange and take the square root and do different things, we come up with half angle formulas. Half angle formulas are useful like the sum and difference formulas are, and that they're going to be a way for us to get exact trig values of more angles than we did before. So like in sum and difference, we can get the exact value of a 15-degree angle because we can take 45 minus 30. But now using half angles, we can employ another technique to get some exact angles. So what are our half angle formulas? So, oops, not use the highlighter. All right. So sine of alpha over 2, I'll use alpha for these. And because we are taking a square root, whether it is positive or negative is really going to depend upon the quadrant your angle falls in. It doesn't mean there's two possible answers. So if the angle we're doing, the angle divided by 2 falls in quadrant 1 or 2, we're going to use positive. If it's 3 or 4 for this one, we would use negative. That's the difference. So this is 1 minus cosine alpha over 2. So you'll see there's a similarity here a little bit to our power reducing formulas. Cosine of alpha over 2, again, depending on the quadrant, whether it's positive or negative, is 1 plus cosine alpha. I apologize, for some reason I'm writing theta when I started with alpha over 2. And just like before, tan is a combination of sine over cosine. So it makes sense that the tan is 1 minus cosine. Keep doing the same thing. Over 1 plus cosine of alpha. So this becomes nice because let's suppose, and again, when using these angles, it's any of our 30, 60, 90, which is our pi over 6, pi over 4 if we're dealing, it's always easier to deal with degrees with these, but if you are dealing with radians, pi over 3, pi over 2, and any angle that has them as a reference angle. So for this example, I'll start with degrees to help you out a little bit. Let's suppose I wanted the exact value of cosine of 112.5 degrees. Well, that is clearly, remember this is our 30 degree, 45 degrees, 60 degree, and of course any angle that has those is a reference angle. Well, 112.5 doesn't fall in any of those categories. But, can I, instead of taking the cosine of 112.5, can I rewrite as a half angle? So wouldn't that be the same as, so if I double 112.5, I get 225 degrees over 2. In other words, rewrite 112.5 as 225 over 2. Now, how does that help me? Well, let's sketch it real quick. 225 degrees, and I did it in degrees to make it a little bit easier. Well, this is 180 degrees. It's going to fall a little bit past that. In fact, it's going to fall exactly 45 degrees past there, right? That's the reference angle, but the whole angle is 225. Oh, well, 225 itself has a 45-degree reference angle. That means we can use the angle 225, where 112.5 has no relation to anything we're doing. The reference angle on 112 What's that going to be? 32.5 or something along those lines. That really doesn't help us. So by writing 225 over 2, I can now rewrite this as, all right, well, let's do a couple things here. Number one, where is, this is what you want to ask yourself. I'm going to put these questions in red. What quadrant is your original angle in? My original angle is not 225. My original angle is 112.5. 112.5 itself is in quadrant 2. Ask yourself, is cosine positive or negative in quadrant 2? Oh, cosine's going to be negative in quadrant 2, so we do need the negative version of this square root. Then it's going to be 1 plus cosine of 225, which we will be able to do, divided by 2. All right, let's come over here to my little 45-degree triangle, which we know is 1 square root of 2. Put the negatives in where they belong. I can take the cosine of 225 using the 45-degree reference angle in quadrant 3. I know my entire square root is negative because 112.5 itself falls in quadrant 2, which is negative for cosine. So what do I have? I have negative 1 plus, what is cosine of 225? Well, that's negative radical 2 over 2. And I just need to clean that up a little bit. And what do I mean by clean that up a little bit? I get rid of the complex fraction that is underneath the radical, so I multiply everything by 2, and that's going to give me, what, 2 minus radical 2, because those 2's will cancel, divided by 4, which is negative 2 minus radical 2 all over 2. Because notice, well, let me draw this a little better for you. That whole thing is under the radical. Now that is under the radical. You will often get a radical under a radical when dealing with these half angles. You'll often get something like that as an answer. So the half angle identity just gives you another way to deal with exact values of angles that are not exactly 30, 60, 90, or pi over 6, pi over 3, pi over 4. It just gets you a way to kind of work them out. All right, and you'll have a bunch of problems on the lab to practice.